So a couple of comments. We're going to look at the written section. I'll give you some hints since you guys are all here after school. First thing, a couple of people have asked, hey, Mr. Dueck, can you give me some extra practice stuff? I yoinked this from the Garibaldi High School physics teacher's website. They got a really good high school physics teacher there who does similar stuff to me, who has a tablet and is techie, although he's got an actual physics degree and he's been doing this for a long, long time. So I went to his website, and on our pitmath.com, when you click for today's notes, I'm going to assume all of you have seen this SkyDrive page. If you go to block B or block G, doesn't matter, click on Unit 2, and then do a sort by date modified. Oh, I like the first one. Hello. I've put extra acceleration practice, extra acceleration due to gravity practice, and then solutions. I haven't looked at every single question to see if they work okay, but they look pretty good. Give me a second here. So if you go to my website, PitMath, click here for today's notes, click on block B or block G, whichever your physics block is. This one here, acceleration, ecto practice. I glanced at this in a hurry. I think every question here looks like it's good and it's fair game. I see some relative velocity. I see a few other things. I see interpreting a graph. Looks like it's good practice. And then he's also put a solution key. And then for the acceleration due to gravity, which is free fall, he's got some good extra free fall practice. And here, this is where I went, oh, he's got a tablet as well. He's clearly doing some of the same stuff I am as well. And here he's showing his showing work and showing steps. Okay, I'm looking at this. It looks like he's using the same method as I am. It looks like he's getting variables by itself and all that. So I hear t equal. I see this. Oh, the only thing I notice is he doesn't use v final and v initial. He uses v2 and v1. I'm guessing V2 is V final. I'm guessing V1 is V initial. Pretty easy switch to make, I think. Okay. So that answers a few of you that were looking for extra or wanting extra stuff. What are you going to need to know? Well, we've been looking at T, D, VI. Those are supposed to be commas, Mr. Dueck, not periods. Get your hands in the right place on your keyboard. VF and A. And as far as I'm concerned, you need to be able to find all of these given any three of these. So what kind of questions might you see on the written section of your test? Well, let me paraphrase a few. You can certainly expect to see something like this. Example 1. A car accelerates from what? How about 60 kilometers per hour to 80, oh heck, let's make them a speeder. 140 kilometers per hour in 12 seconds. What is their acceleration in meters per second? Oh, squared. Control Shift equals. Okay, now I know how to do exponents. What's this question asked me to find? Okay, so we would start out, what I've taught you is a little DFIC approach. And again, you're probably at a stage where you can modify or use as much or as little as you want, but I'm trying to give a systematic way. I tend to almost always say A equals question mark. I feel better. I've written something down. I've identified what the heck they're asking me to find. Then I walk through the question. That's 60. What's that? That 140, what's that? That phone in your hand, Ty, what's that? Away? You can do better than that. That 12, what's that? Time? So, so the skill you need to have, you all have a formula sheet if you're in my class. I imagine Mr. Kamosi has given you some kind of a formula sheet, and if not, they will be on your test, on the top of your test as well. We're looking for an equation that has those in it. Which one? Now, I got to be full honest. If you are at a stage where you can't find the equation, you need to be really doing a lot of practice tonight. I'm not saying you have to be at the stage where you can rewrite these in your head. I'm not saying you have to be at a stage where you can solve these in your sleep. But if you can't find the equation, that part, all I can say is practice a bunch and get the hang of it. So you're okay with finding the equation? It would be and I think Mr. Kamosi has done the same thing. We've been teaching you to actually rewrite these equations, hopefully in your head. I want to get the A by itself. How would I get the A by itself? Well, the first thing that I would do is I would move that over, because I always do my dividing last. Because there's two things. Brad, you can see I got a VI and I got a T. Yes? How would I move that T over? Divide last. How will I move the VI over? And the VF just stays where it was. So what I think to myself is this. The VF stays where it was. You're saying I would minus the VI. I would divide the T. And if it's okay, can I put the A on the left-hand side instead of the right? Because that's how we're used to writing it. Yes? By the way, what's the other problem with this question? What else don't you like? Do you see it? Do you see it? Do you see it? And I'm going to do a couple like this on your test. The units. Almost everything will be in meters per second and meters, like in nice units. You know what? There's going to be 2, maybe 3, where I'm going to go kilometers per hour or hours or minutes. So you should be able to do the basic conversions. What's the shortcut? How do I go from kilometers per hour to meters per second? Turns out it's oh, 60 divided by 3.6 is what? 16.66. So I'll go, because I don't want to round off. I'll go 16.667. I'll carry 5 sig figs, assuming that I'm going to round off to 2 or 3 sig figs in my answers, depending on what information they gave me. So I'm going to go 16.667. And 140 divided by 3.6. I'm going to go 38.889. So that means this is going to be 38.889 minus 16.667 divided by 12. Can you all tell me, if I were to type this, because this is what I saw a lot of my physics 12s do and it drove me crazy, if I were to go like this, why is that wrong? Where? What? How? Okay, more than one number on the all this is going to tell my calculator to do is to divide the 16.67 by 12. It won't know to divide the whole thing. So make sure this is, oh, have I gone on the occasional calculator rant in my classroom? Maybe. But are you cluing in I had good reasons for it? You guys have bought into it now. You're going to bring a calculator to the test? Yes? Yeah. First time for everything. Expecting that it'll go a lot smoother with than without? Okay. I get an acceleration of 1.8518. How many sig figs? Well, technically 1. Let me do that. There. How many sig figs should I go in this question? I see 2, I see 2, I see 2. 2 sig figs. So I'm going to say 1.9. 1.9 units for acceleration. Got to memorize your units. Well worth doing. Meters per second squared. Okay? You're going to see one like that. Guarantee it. You're going to see one like that. I guarantee it. How about something like this? Example 2. A car starts from rest, and after 32 seconds reaches a speed of, oh heck, let's have this sucker really going fast, 82 meters per second. How far will it have traveled? A car starts from rest and after 32 seconds reaches a speed of 82 meters per second. How far will it have traveled? What's this question asking me to find? Good. All right. What else do I know? Yeah, so you started to spot this word from rest or stopped are really the two big ones. Oh, dropped if we're talking about free fall. So VI is 0. What else? T equals 32. What else? I'm looking for an equation that has those in it. This is the equation we've barely ever used, but this is about the only time you need to use that equation. Which one has D, VI, T, and VF in it? Go ahead.
D equals a half VI plus
You can either think of it as over 2 or dividing by 2 is the same as multiplying by a half, doesn't matter. Then I'd say get the D by itself. Oh, conveniently I do have the D by itself. By the way, the reason we hardly ever use this equation is it's kind of redundant. Darian, I could actually use those 3 things and I could find the acceleration.
Mr. Cater, please come to the
And if
office,
I could
please.
find the
Mr. Cater, please come
acceleration,
to the office.
then I can use, if I know the acceleration, then I can use D equals VIT plus a half AT squared and find D. So in physics 12, we don't even give you this bottom equation anymore. It's a waste of time. It's a waste of space. It's, But physics 11, we still give it to you. We use this equation to derive D equals VIT plus a half AT squared because that's a much more powerful equation. But here, the D is by itself, so it's going to be plug and chug. Oh, and why can I do that? VI is 0. So this is going to be a half, which on my calculator I type as 0.5. VF, 82. 32. Sig figs looks like 2 sig figs, so I guess I would go 1.3 times 10 to the 3rd meters if I was really being fussy on sig figs. I don't know if Mr. Kamosi what he's decided, but I've told them I'll emphasize sig figs, but I won't take marks off for sig figs. In other words, I'll teach it to you right, but I'm not going to scream if you have trouble on tests. I'm testing your physics, not your ability to do the sig fig thing. I gave you a test on that already. Good enough. So far, so good? Could you find the acceleration? Yeah, the same way we did right up here, example 1, for that matter. So something like this might even make a good 2-parter. Hey, find the acceleration. Hey, find the distance. Okay. Relative velocity. What kind of a relative velocity question am I going to throw at you? Well, how about something like a police car is traveling at 120 kilometers per hour. It sees the bad guys 225 meters ahead. If they want to catch up to the bad guys in, I don't know, 6.0 seconds, how fast do they need to travel in kilometers per hour? This will be the other type of a unit conversion question that I give you. In fact, to me, this is arguably one of the toughest questions. And I'll even give you, since you guys are here after school, a really blatant hint. Your first written question is going to be the relative velocity question. And I'm doing that on purpose. I'm giving you the nastiest question right away because I want you to realize that questions don't always go easy, 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 medium, 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 tough, tough, tough. One of the things you need to learn is how to deal with a tough question and then expect that there's an easy question. I don't know about you. Grant, I was one of those irritating kids in high school that got high 90s. When I was writing a test, if I came to a question that I didn't know how to do, I was psyched. You were psyched, Mr. Dueck? Yeah, I was psyched. Because I knew that I'd studied so well that the odds of me not knowing how to do 2 questions were never going to happen. If I came to a question I didn't know how to do, that meant I was getting perfect on the rest of the test. There was no way I wasn't going to know 2 questions. Some of you want to start being that arrogant, that prepared, that, hey, I'm going to spike this stuff down, I'm going to nail this, I'm going to master it, I'm going to learn this. What I'm saying is, one of my few peeves as a teacher is when I hear a kid say, oh, I passed. You know, Tawny, you set your goal to pass. You know what you're going to achieve? A pass. You're all better than that, every one of you. So, high goals, high expectations. And so one of the things I try and do, Carly, then, is I try and throw you curveballs sooner than normal. Sure, why not? So here's our relative velocity. What's this asking us to find? In fact, I think what we're going to find, is there more than one vehicle, Carly? Are they traveling at different speeds? This is a job for relative velocity. If they had given me both the speeds, I'd use the relative velocity to answer the question. Did they give me both the speeds? No. Okay, so yeah, this works. I wanted to make sure I could handle this, okay. Sees the bad guys 225 meters ahead. I said this. Sure, this works, I think. Sorry, back to where I was. If I'd given you both velocities, you would use it to find the relative velocity. Since I didn't give you both, let's find the relative velocity and see if we can figure out how fast they need to be going compared to the bad guys to be able to pull this off. Okay? So right now, we're assuming both the bad guys and the cops are traveling at the same speed. The cops are going to floor it. How far do they need to cover? What's the distance they need to travel? What's the time frame they have to do it in? And if it's a relative velocity question, I've told you the acceleration is going to be 0. I'm not going to give you a combined question. And that's why, by the way, Carly, I didn't say V final or V initial. I said V relative because you know, it's the same. Hey, what's the equation I could go to here? Except, Brad, yoink. Except, yep. And in fact, you could make an argument. I could even, Eric, do this, because it's initial fun. What? It's V relative. Speaking of, how would I get the V by itself, kiddo? So, V is going to be D over T. I'm making these numbers up. I have no idea if these are in any way going to be physically possible. I was trying to do the arithmetic in my head. They have to be going an extra 37.5 meters per second. They have to add 37.5 meters per second to their speed relative to the bad guys if the bad guys are going at are also going at 120 kilometers per hour. Well, we wanted kilometers per hour. Ah. Oh, 135 kilometers per hour. This is what happens when I make up numbers. So looking at this data, let's use red for a police car. They were traveling at 120 kilometers an hour, same as the bad guys. What do they have to increase their speed by? Oh boy. I mean, I like this has worked out fairly evenly and nice, but I'm not sure a cop car can get to 235 kilometers. 250, in fact, I'm pretty sure a cop car can't get to 255 kilometers per hour. So I made up bad numbers, but the method is okay. Yes? Yeah. I'm going to ask you some questions about free fall. Learn to type. Free fall. Oh yeah, my computer doesn't recognize. You know what? I think that's a word. Free fell. Add to dictionary. Free fall. So, stuff like this. Example, is this 4? Yeah, it is. Oh, 8.9 seconds. If I tell you that we drop a rock from a cliff and it hits the ground after 8.9 seconds, what can I ask you to find? I could ask you to find that. Again, the key to doing this question, Jake, is this word here that tells you lots of information. What does it tell us, Chris? Which is? Disagree. I think A is negative 9.8. But it does tell me VI, because this is meters per second squared, right? But it also tells me VI. What's VI? Ah! By the way, Chris, what's part A asking me to find? Which is, because high is not a variable in my formula sheet. When they say how high, what are they really talking about? Oh, D? Right? And there's one more thing the question told me. What? Have I got an equation that has D, VI, T, and A in it? Our old friend. Conveniently for dropped, I could do that. Oh, they gave me the time. I can get the D by, the D's already by itself. Holy smokes. So this would be plug and chug. 0.5, negative 9.8, 8.9 squared. 0.5, negative 9.8, 8.9 squared. What's the negative telling me? It's telling me I ended up below from where I started. Did I type this in right? A half mv. Yeah, I did. So the height of the cliff, I'll call it negative 388 meters. But since height's technically a scalar, if you just said 390 meters, I'd accept that. But my equation gives me a displacement. I'll take either. Leave it as a negative, and I'm fine with that. What else could I ask you to find? Not just, oh, I could ask you to find, except I wouldn't say V final. I would say the final velocity. Tawny would be tempted to say, well, Mr. Dueck, isn't the final velocity 0? But she would catch herself, and she would say, no, that's after we've gone to a whole different situation. That's after we're no longer in free fall. That's after we've come to a stop. But this is a free fall question. So V final, I would say that. Can I find V final using the data that I have listed here? Mm-hmm. Yeah, how? I could even probably use the D. Oh, you know what? Just in case I got the D wrong, or I know I have rounded it off, I'll avoid using it Ty if I can. It's going to be VF equals VI plus 8. Oh, this is nice. The VF's already by itself. Holy smokes. Oh, even nicer, I can say to myself, self, woohoo! What's the negative telling me? It's going down. It's going down. Negative 87.2, or negative 80, I guess I should go to 2 sig figs, negative 87 meters per second. Okay. What else could I ask you? I guess I could say find the velocity after 3 seconds. That would be the same as part B, except I put a 3 seconds in for the, like I could ask you to find the velocity at any time before it hits the ground.
Are you gonna do that?
Could. Yes. Taylor, you had a question? Oh, you were just stretching up there for, okay. Instead of dropping, I could say this. Baseball is launched upwards from, well, heck, from the ground at 25 meters per second. So if we throw something straight up from the ground, what is the maximum height? What's this question asking me to find? Yep. What else do I know?
Acceleration.
What's the acceleration? Okay, what else do I know? VI? This is not dropped, so VI is not 0. What's VI? Oh, 25. That's not enough. Oh, at the top for a split second, so this is something else you want to be aware of, right? You've thrown, I'm assuming all of you have thrown stuff in the air as kids, or maybe even as young teenagers, and noticed, oh, at the top for a split second, if I can get it to go straight up, it comes to a stop. I'm looking for an equation that has distance, acceleration, initial velocity, and final velocity in it. Trish, what am I trying to get by itself, dear? So I want to get that thing by itself. See it, see it, see it, see it, see it? What will I do with the 2a that's in front of the d to move it over? What's the two? What's the? I'm going to divide. Do that last. What else do you see on this side? That guy. How will I? Vi squared, right? How will I move the vi squared over? Minus it and then divide. Yeah? So if I hear you correctly, and I think I do, you're saying, Mr. Dueck, if you drop the VF squared where it is, leave it where it is, you're going to minus a VI squared over to that side and divide the whole thing by a what? And now you're going, Mr. Dueck, this is almost too easy. Remember how tough this was for a while? Hopefully it's coming together. I hope. Yeah? Nice. Now, have I got the D by itself, Chris?
Yep.
Then you know what I call this?
Plug and play.
You know it. VF squared, 0 squared, minus VI squared, 25 squared, all over. That's a terrible looking D, Mr. Dueck. There we go. It's going to be, and of course, Jake, brackets around the top and brackets around the bottom. I heard you there, right? I thought at the top looked like it was going to be negative, but then I saw there's also a negative on the bottom, and this is good. I get a negative divided by a negative, which is what? Which is what I want, because at the top, am I not above myself? Like, it should be a positive, yes? $31.9? Or 32 if I went to 2 sig figs? Well, what else could I ask you to find here? Could I ask you to find the time to reach the top? Sorry? Could. I think, Brad, I would do this, yes? I could read dfic, but I have everything on the same screen. I can use D if I need to, but can I find time using VF, VI, and A? Yep. I can. What's the equation that has all those in it? All right, get the T by itself. I agree with that. That's pretty obvious. Yep. By the way, VF is 0. I could have crossed it out. I'm always reluctant to cross out something when it's the only thing on that side, because that terrifies students, because then they're like, ah, half my equation vanished. So I cross out zeros when there's more than one thing on that side, because that makes the equation simpler. But if I had done this, I know what happens. A lot of students, desperate, not knowing what to do, they just magically move the equal sign right to, which is wrong. Can't be doing that. So, in case you've ever wondered why I'm inconsistent in when I cross stuff out and when I don't, I cross stuff out when it makes it easier, not tougher. Hey, Jake, what can you tell me about the top of this when I type this in? I think you are. It's going to be 0 minus, what did I say my initial, 25. Divided by, what's, oh, free fall, Mr. Dueck, negative 9.8. And again, this is nice. You can see, Jordan, I'm going to get a negative on the top, but I get a negative on the bottom. Holy smokes, I get a positive time. And that's the one thing that is going to be positive this year. Time is a scalar. No negative times. Well, I heard that Einstein said you can travel backwards. No negative times for projectiles. Okay? Zero, take away 25, divided by negative 9.8. Looks like about 2.55 or 2.6 seconds. What else could I ask you to find? This one is so easy that it's tough. What word did I just highlight? So how high are we starting? At a height of? No. How high are we starting? From a height of? How high are we ending? From a height of? What goes up must come. So what's the final velocity? Negative 25. What if this was a cliff? Okay, if this was a cliff question, then I would have to find V final, and I'd probably find V final, as a matter of fact, using VF squared equals VI squared plus 2AD. How would I get the V final by itself? How do I get rid of the squared? Square root. Okay. So V final. I can only use what goes up must come down if I start and end at the same height. Otherwise, I got to do some number crunching. But that can be handy. What else? You will be asked to sketch some V versus T graphs given D versus T graphs. Okay. Where does velocity appear on a distance versus time graph? Key idea. Velocity is the slope on D versus T, and it's the height on V versus T. So if you see, for example, well, really quickly, if I gave you this, hey, what if you had a something like that? Imagining it's a straight line. What would the velocity versus time graph look like? Yeah. No. What were you? All lines are straight. By definition, you mean a horizontal line. You can't be a line without being straight. Is that what you're saying? Okay. Hey, actually, what if this was steeper? Hi. Oh, wow, that's terrible. Higher. This is harder than it looks, okay? Hey, what if I had a yoink down there somewhere? What if I had this? Right? Oh, hey, let's get really tricky. What if I had this? That would be an increasing velocity, getting steeper, getting steeper, getting steeper. Okay? So I'm going to give you some graphs to do quick sketches of a before and after kind of a dealie. What else are you going to see? You will be asked on my test to graph some data and interpret it. Two possibilities. D versus T. I'll ask you for the velocity, or I'll give you velocity versus time. I'll ask you for the acceleration. If you carefully graph on graph paper a distance versus time graph, and I say, hey, tell me the velocity, how the heck would you find the velocity? Slope, rise over run. I won't give you a curved one, because you need calculus to do that. I might give you a graph of a curved one and say find the instantaneous slope by laying your ruler down, but that I take a lot of leeway. Or if I give you the velocity versus time and ask you to graph it, how the heck can you find the acceleration? How the heck can you find the acceleration if you do a velocity versus time graph? It's also the slope. Okay? So the odds are I'm going to ask you to go rise over run. That's pretty much everything you're going to see in the written. What's the multiple choice? Lots of conceptual, but also lots of similar to the written, just as multiple choice questions. Basically, again, you need to be able to handle free fall. You need to be able to be comfortable with the D, VF, VI, A equations and be able to rewrite them. So having done that little summary, are there any specific questions from the review or from any of the homework or any other things that you would like me to go over? Now is your chance to ask. Okay. Are you writing tomorrow?
No.
Okay.
Thank you.
I'm going to go longer, so if you want to print out, I'll also email this as a PDF attachment to everybody, so I'll print it out for people that can stay the whole time.
Thank you.
When's your test? Yes, okay, you're ahead of the game for a while. See me tomorrow when I can print this up for you if you want, because I don't have your email anymore. Any questions for the rest of you? Yeah?
6 and 7.
From where? On the unit review? It's right at the end of this. Hey, Mr. Dueck, where'd you put the unit review? Unit review combined all three. I think this is what I want. So, sorry, Darian, which one? Whereabouts? This page here? The Voodoo Aircraft one? Okay. Yo. Okay, are you writing tomorrow? I'll email this out in about 45 minutes or so, and you can get the PDF copy. A Voodoo Aircraft.
Which version is this supposed to be?
I don't know. I was expecting from the Velocity Acceleration Unit Review, number 6. Okay. What's this question asking me to find? This is an application question, Darian. What's it asking me to find? I think when it says, does he make it, what's his time limit? I need to solve for t, and if t is less than 40, he survives. If t is more than 40, and I'm going to have to do some unit conversions here. So I'm going to write down Is that okay? Hey, is this question giving me any kind of acceleration anywhere? No. Let's assume that we're gunning it at a constant speed. You hit the afterburners, and once you've hit the afterburners, you can't speed up anymore. Is that okay? So that means V final, V initial, V are all the same. What's V? Well, it's 1600, but I'm going to divide by 3.6 because I want that, I think, in meters per second. $444.444. And it looks like the distance we're traveling is 1,000 kilometers, which is that many which is 1 times 10 to the 6th meters. It's 1,000 kilometers, and I know each kilometer is 1,000 meters, so I just added 3 zeros. You with me? Okay. I think I'm going to go this. I just skipped a bunch of I went D equals VIT plus a half AT. Wait a minute. What's A? So I went D equals VT, and I got the T by itself. This is very similar to the relative velocity one that we did a little while ago in terms of the setup, where you're getting late, so I'm cutting corners. That's okay? So I think the time is going to be 1 times 10 to the 6th divided by 444.4. It's going to be 1 times 10 to the 6th divided by that answer that's still stored on my calculator. In seconds, it's going to take 2,250 seconds. How many minutes is that? How can I change this to minutes? Yeah, and if you're not sure, pick easy. If it was 60 seconds, how many minutes is that? How do you change a 60 into a 1? Divide by 60. If it was 120 seconds, 2. If it's 2,250 seconds, divide by 60 seconds per minute, if you actually want to fit the units in. 37.5 minutes. Does he make it? Barely. 2.5 minutes to spare. Is that all right? Yeah. Sorry? I would feel comfy as multiple choice. There's 15 multiple choice. So 15 marks. Test is out of 40. 15 marks worth of multiple choice. 25 marks worth of written, including sketching a couple of graphs. Well, I'm not done. Darian, what was your other question? 7? Ooh, relative velocity. So this is a good one. So this is very similar to, I think it was number 5 on the relative velocity practice sheet. Come on. Okay, let's go over here. A car starts out from blah, 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 blah. Okay. Is there more than one object? Are they both moving? This is a job for relative velocity. They're heading towards each other. So I have, it seems to me, Vancouver and Chilliwack, and the distance between them, 90 kilometers. A car from Chilliwack, Ford Escort, how about I use E for Escort or F for Ford? What do you want to use? F for Ford. So in Chilliwack, I'm going to have a velocity of a Ford, and it looks like, you know what? That F is going to make me think V final. I'm going to use there, V for Escort, so I don't get confused here. It's heading out at 110 kilometers per hour. At the same time, a Jeep is leaving at 80 kilometers per hour. Darian, what are my units here? How about here? How about here? You know what? I don't think I need to convert this to meters per second. I think I can do all of my equations with kilometers and hours because my units are all nice. They match each other. Sorry? And then I can do the conversion at the end, but I don't think that, I think this one here, I left the answer in kilometers, if I recall. Pretend one of these guys is standing still. That means the relative velocity is, hey, what's the relative velocity? 190. Oh, and how far, if one of them is standing still, how far are they traveling? 90.
Mr. Guzik, you have visitors down in the office. Thank you.
And, oh, I told you that for relative velocity, it's always going to be that. Could I find that? Yep. In fact, strangely enough, it's going to be exactly what we did right here. It's going to be d equals vit plus a half at squared. A is 0. You know what? It's going to be, get the t by itself. The amount of time in hours that they travel before they meet each other, because in real life they're not both standing still, but we're just pretending they are, is going to be 90 divided by 190. They're going to travel for 0.47368. I'm just going to write 0.47 hours. Now that is if one is standing still and the other one covers all the distance. Is that what's really happening? So I'm going to let the Jeep travel this way for 0.47 hours. I'll let the Escort travel that way for 0.47 hours. They'll meet. Where? Let's find out. So let's calculate the distance of the Jeep. That's going to be Vt plus a half a. Oh, A is 0? Vt. Which V? The Jeep's actual velocity now. What's the Jeep's actual velocity? Times 0.47 hours. This number times 80. You know what? It's going to be 37.9 kilometers from Vancouver. Or if I go 90 minus 37.9, that'll tell me how far we are from Chilliwack. Is that okay? Grant, you had a question?
Thanks, Mr. Dueck.
Do you guys want me to print this up for you? Or I'll email this out.
Thanks.
It'll probably take about an hour to upload this video, so you'll get it hopefully around 5:30-ish, assuming all the Wi-Fi stuff doesn't go kaputski on me, which is a bigger assumption than you realize sometimes. Sorry, Grant, what was your question, kiddo? Number 8? Okay. So here's a graph. What's its displacement? So 8a, let me shrink this down a tiny bit. Yoink. Turtles Adventures. By the way, you saw my answer key that I put online for this, showing my steps? Because I didn't attach the answers, but if you go to the website, pitmath.com, okay, I did put this, and I also attached it to an email for you guys on the weekend, right? Which, of course, you checked this weekend, right? Okay, so there is answers showing my steps if you get stuck. Okay, because, of course, you checked your email that I sent out on Friday, right? This being Tuesday, right? But because I like you, let's redo this one here. Okay. What's part A asking me to find, Grant?
Displacement.
What's on the y-axis?
Distance.
Okay. You know what? Because it's got negatives and positives, I could probably technically talk about the displacement in terms of direction. Since we're walking along the equator, What would a negative distance from the equator be? I think south. Yes? And a positive would be north. Whatever. I'm not going to give you one quite this vague on your test. On test, I'm much fussier about the way I word things so that there's no, not quite sure what he's getting at stuff. I want it to be very, very clear. But at 0 seconds, displacement at 0, how about negative 4 centimeters? Or you could say 4 centimeters south of the equator. How'd I get the negative 4? It's the height. Displacement will be the height. What about at 10 seconds? Actually, sorry. What about at 7 seconds? 7 seconds. Yes? 6 centimeters north. Ah. I think I would, actually, because displacement is change in position. Where did we start? Here. After 7 seconds, where are we? Here. How far is that? What's our change in position? And I think that's what my answer key did say. I hope. Let me double check. Distance at 7 seconds. Did I say 6 centimeters? Yeesh! Mr. Dueck needs to fix his answer key. Yeah, I think I would argue 10 centimeters. You're right. If I had said distance. Although I did did I do a displacement for, no I didn't. Oh, I got to fix my answer key. Vanessa, candy for you, my angel, joy of my heart. Give me a second here. Whoops, note to self. So yeah, I think the displacement would be, okay. What about the displacement at, say, 11 seconds? Well, we start out at 4. We end up right here. You know what? I think the displacement at 11 seconds is just, because displacement is change in position. Now, distance would be very different. Distance at 11 seconds would be you traveled this far. Look up. Let's try that again with you looking up. You traveled this far, then you traveled that far. Total distance you traveled was from here to here, 11 centimeters on the way up. And then from here to here, I think 10 centimeters on the way down. I think you could argue the distance, I think it's 21 centimeters. I think. Let's erase all this marking up. Is that okay? Then what does it ask? Part B. Oh, distance. We talked about that just now. So what's the total distance the turtle has traveled at each of the above times? That would be the distance as well, I think. Oh, you know what? B says distance from the equator. C would be total distance. So D is just how far from the equator. That would be its height on the graph. Okay? Then I did average speed and average velocity. So average speed and average speed is distance over time. Average velocity is displacement over time. And now that I'm looking at this and think I did my displacements wrong, I'm not going to show you my answer keys. My answer key might be wrong, but I'll fix that later. And then part E says using tangent lines. So this was the tricky part. Find your instantaneous velocity at, let's do 7 seconds. Okay? No, let's do, what's the first time it gives you? 2 seconds. Let's do that. So here is 2 seconds. What I'm going to do then is I'm going to use a ruler and I'm going to lay my ruler down. I'm not going to lay my ruler down like, that'd be terrible. That's not even close. I'm going to try and eyeball about like that, I think. That's pretty good. And the slope is going to be, ooh, wonderfully, I happen to go right through there. And there's another point that I went right through there. I can use that. Yours, because you have your ruler laying down a little bit differently, you might be going through different points. For instantaneous slope, I'm pretty lenient. The rise would be 1, 2, 3, 4. The run would be 1 second, 2 seconds, 3 seconds, 4 seconds, 4.5, because the scale isn't going up by ones along the bottom. The vertical axis is going up by ones, yes, but the horizontal axis, every other square is 1. So it'd be 4 over 4.5. the instantaneous velocity for me would be approximately whatever the heck that was. 4 over 4.5. I'm getting about 0.8 or 0.9 centimeters per second. Wonder if I had that right in my answer key, Mr. Dueck. That was the at 2 seconds? 0.86. So when I did it, yeah, I just got 0.88 or 0.89, 0.86. It's all in how slanty your lines are. But so I'd mark within a range. Is that all right?
Yep.
Answer your question okay? Any others? Yeah.
Number 7 on the acceleration review.
This number 7 here?
No.
This one here? Same deal. I'll email this out, but those of you that stick around, I don't teach you anyways, do I? No. Well,
Thank you, Mr. Dueck.
been there, done that. See ya. Do you have your formula sheet? Have we got any equation that includes, yeah, the average? I don't use these very often. Let's see. Where is my formula sheet, Mr. Dueck? Formula sheet. Average velocity is displacement. Okay, I got that there. Yeah? See what I can do with that. Or, well, I got this here. Or, it's asking me for accelerate. Ah! Let's see here. I know that D equals V av times T. Is that okay? I got that right from the formula sheet. So I guess I can find time. I don't know where I'm going, but I can certainly go, time is going to be 500 divided by 24. Distance divided by V average. I'm getting a time of 20.888, 20.83. How's that help? Well, I got a time I know how to get there, but I need to think in physics 11 terms. And I didn't catch this one. I shouldn't have assigned this one, but that's okay. Oh, for Pete's sakes. I missed a key physics word. Ah. Yes? I'm sorry. I missed that. That was dumb of me. Because they told me V average is 24. I can find V final. Do you know how? How do I find the average of anything? The average of anything is add them up and divide by 2. Add them up and divide by 2, which I guess means that if I want to get V final by itself, take care of that divide by 2 first. How would I move the divide by 2 over? 2 V average equals VI plus VF. How would I get the VF by itself? You know what your final velocity must be? 2 V average. Oh, wait a minute. V initial is 0. I could have done this even cleaner than that. V final is going to be twice V average because V initial is 0. V final is going to be 48. Is that okay? So now, oh, I don't need this. I have V initial, yes. V final, D. I'd like A. Is there an equation that has V initial, V final, D, and A in it? Yeah. Squared equals VI squared. Let's get the A by itself. A is going to be, I think, VF squared take away VI squared divided by 2D. Yeah. Which, oh, and VI is 0. So it's going to be VF squared divided by 2 times 500. Please tell me that works. This is my fault. I should have read the question, Carly. And how about also not typing an extra 0? Yay! 2.304, or 2.3 meters per second squared. Okay. I'm not going to give you one that tough on your test, but if you followed that, you're in good shape. If you got that, you're in really good shape. Any others, kiddo? Any others from anybody? You awake, Sally? Yeah? Going once? Okay, let me pause the video and then I'll print this up.